Let's model net interest income, or NII. Net interest income is the largest income position in a bank. Um, Apart from net interest income, we have recurring fees or transaction fees and trading fees. But now we are going to concentrate on NII, which is the largest, the most important, and the most difficult to predict. So, net interest income is equal to interest income minus interest expense. Let's create a hypothetical case of a bank um, which will of course be less complicated to plan than reality. So let's start with assets because we're now calculating interest income. And as far as assets are concerned, the most important positions are loans and all possible investment securities. Let's call it like this. By the way, the most important way of how banks make money is making loans and taking money from customer deposits. This is actually the banking business model. So we have stopped on assets and we have concluded that we have loans and investment. Let's have, for example, $60 million of loans and $300 million of deposits. And let's now have a look at liabilities. We have already mentioned that uh, the banking business model is making loans, creating loans and getting interest and taking money from customers by issuing deposits. So let's write deposits. And that will be the largest position, let's say $500 million, and all sorts of funding. We're now making a less complicated model that you will meet in most banks because both funding and investment securities are not very homogeneous, and to provide a better and more precise planning model, we need to have more granularity. But in this particular case, let's imagine we have 200 million US dollars of funding Here we have only listed the assets and liabilities which generate interest. So let's sum up. How much do we have? 500 plus 200 will make 700, and 600 plus 300 will make 900. In terms of loans, let's imagine that we have fixed and floating rate loans. So we will have say not necessarily 50%. Let's make it 70% of fixed loans and 30% of floating rate loans. Fixed rate. Voila. What else should we have a look at? Another important issue would be related to deposits. The practice shows that deposits are rather sticky. By deposits, we mean the money that we take from clients and use it to generate profit, either by issuing credits or by doing some other operations. And deposits, as such, are internal. I mean, we have internal discretion over them. By that, I mean that we can change them, the conditions that we pay the clients for giving us their money or not. And here we have the so-called deposit beta. Let's make it like this. Deposit beta, which is a coefficient showing us how actually sticky deposit rates are. Stickiness of deposit rates, and that will be equal to 0.4. We are now going to calculate interest income and interest expense in normal conditions. And we are also going to simulate a shock in interest rates. And we shall need the listed pieces of information when we are going to simulate this, the effects of that shock. But for now, let's calculate the income and expense under normal conditions. We have loans. We did not actually establish the rates. In reality, the rates, as I've already mentioned, would not be as homogeneous. There'll be different rates for all sorts of securities. We should also take into consideration maturity of securities and some other aspects which will affect our rates, from which we're going to calculate weighted average. But for now, we have normal, less complicated conditions. We'll have for loans, let's say we have 5%. From our investments, let's say we have overall 3%. From liabilities, for deposits, we're going to pay our clients, let's say 4%. And for funding, we're going to pay 2%. And now we have all the conditions that we need to calculate the interest income and interest expense. We shall call the rates for assets yield, and for liabilities we shall call them cost. That will be easy, just distinguishing those two as parts of the balance sheet. So yield and cost. Interest income. We'll make loans 6.5%, 300 per 3%. Interest cost. For deposits, we shall have 500 per 4%. And for funding, 200 per 2%. Let's make some space and calculate net interest income and also margin. For net interest income, we shall have interest minus expense. And now we have 15 million. Let's write it down here. I think I have just extinguished the values. It's also very good to write the currency. Looks more professional. And let's calculate the margin. Net interest margin is calculated as a proportion of net interest income to interest-bearing assets. One last important thing which I have forgotten to mention is actually that for our calculation, for our modeling, we use average assets and average liabilities. By that I mean that we take the assets from period T, add the assets from period T minus 1, and divide it by 2 to get the average. As easy as that. But now we need to consider a highly probable scenario of interest rate rise in interest rate. Let's call it rate shock. So that will be 100 bips rate shock. And let's discuss what happens. If central banks increase their rates, that will not be reflected equally on loans, investments, deposits, and funding, for different reasons. In terms of loans, most probably they will be reflected quite accurately. And if we have 1% shock, that will be um, translated into rates we receive by loans. So we shall have 6%. For investment as well, we pay loans. We make loans and get interest from them, and we also invest our money in similar instruments which also want to gain money. So uh, most probably we'll receive a high interest rate. Let's say 7%. Oh, sorry, not 7%. We have 3. We'll receive 4%. But in terms of loans, I think I've forgotten something. Specifically, I've forgotten the fact that we have fixed rate loans and floating rate loans. For fixed rate loans, we've already negotiated a certain fixed rate, so it will not change. Let's say we have 70% of fixed rate, so that will be 70% of 5%, the initial rate, plus the rest, which is 30%, will be subject to increase in interest rates. How much shall we get? We shall get 5.3%. In terms of investment, well, it depends. Sometimes it will be translated and sometimes not. In certain securities, we'll have high interest rate, and for certain securities, not necessarily. So let's keep it unchanged, but not 4%, but rather unchanged. What happens to deposits? I've already mentioned that the deposits are sticky and we have 0.5% beta. What does it mean? It means that when interest rate rises, the banks are not really in a hurry to increase the cost of the money they use. And that will be that will be augmented through this beta. So what we have now? We have now 4%. In normal cases, that would be 4 plus 1, but it's not 4 plus 1 because we get not 1%, but rather 1% multiplied by beta, which is 0.4. So that will be approximately 4.4. Voila. In terms of funding, well, we increase our loans, and we shall also pay when the central banks increase interest rates, where we are also going to pay higher rates. So the funding rate will increase, and that will be 2 plus 1. Those are the new rates, and once again, those are very simplified version of simulation in reality. Let's call new rates. Let's now calculate the interest income and interest expense that we shall get under those conditions. Expense, not cost. So 6 by 5% will get slightly higher profit from loans, the same income from investment. And what about expense? Say 22, slightly higher expenses and higher funding. Overall, what we get here? We get here higher interest income, higher interest expense, but will the net interest income increase by as much? No. And what do we see here? We see here that we are a little bit dragged down by expenses, by liabilities. And as the interest rate increase, we have more impact from expense generating liabilities than assets. Let's calculate the margin. The margin will be 12.8 divided by average assets. And that will be 1%. So the net interest income will decline by 2 $2.2 million. And net and margin will also decline. This is a very simplified version of net interest income modeling. What we're missing here all sorts of hedging, banking book compensation, all sorts of maturity, accommodation, and other things which make the model much more difficult. And another point is that net interest income is only one of the income positions. Apart from net interest income, we have transaction fees, trading fees, and all sorts of fees which we regard as, let's say, non-interest income. And if we are more interested in how much liability remains, how much, how sufficient is the income provided by a financial institution, we shall create a metric called PPNR, which is pre-provision net revenue, and it will be equal to NII plus non-interest income and minus non-interest expense. If you want to go into the direction of risks, Basel, etc., we are more interested in PPNR than NII. But if we are interested in profitability of a financial institution, that we should first and foremost look at NII. That's it. Thank you for attention.